Hello and welcome back to my RC channel. I'm AndyRC and today I'm going to buy, build and fly a 130 sized brushless micro quadcopter. Now, I have had this requested quite a few times on the channel, so here it is. So this build video is going to be much like my other videos where I go and shop for all of the items and then we build it, tune it and fly it. Now, this one is a little bit different because I'm starting off with a kit from gearbest.com. Now, this is a pretty nice kit. They call it the GB130, and it's got some pretty nice components in it. So let's check out what components you actually get with this kit. So it's £146, which isn't bad at all. It comes with an SP Racing F3 flight controller. We have got the RX130 frame. We've got an RP SMA Omway antenna, a RunCam FPV camera, which is CCD, which is really nice for this kit. And then this is interesting, it's a 25 milliwatt to 600 milliwatt selectable video transmitter with a built-in 5-volt regulator. And here is the star of the show. It is the Emax RS1306 4000 kV motor. This is going to provide some crazy thrust. Now the ESCs are just the DYS 10 amp BL Heli ESCs. They only support 1 to 3 cell. Now I did think about making this a 4 cell model, however you will see later why I have kept it 3 cell for now, and I may change it to 4 cell in the future. So we're given some dowel props here. They are the 3045 props. You're only given one set in the kit. However, these are really durable, but I do recommend that you buy some more. So really nice components there. Now, I have changed a couple of things though. This frame comes with a power distribution board that doesn't have a built-in regulator. Now, the idea is that you plug the VTX directly into the power distribution board and its onboard regulator will filter out any noise. However, I found with these small VTXs that they're not very good at doing that. So to try and combat any noise issues, I'm going to replace the power distribution board with one that's got a built-in BEC. So I'm also going to be replacing the XT60 connector, and that is because the majority of 3-cell batteries use a JST connector at this size, so it's going to be an 850 milliamp battery. So I'm going to do away with the XT60 connector. But yeah, pretty nice kit that is. So the power distribution board, I'm using one that I've got in my spares bin, and it's not really very good. It's very cheap, only £3.17 from Banggood, and I would recommend spending a little bit more money because the regulator on this thing isn't very good, and even though it's going to filter out a lot of the noise, I found that a little bit of noise still filters through, but it's nowhere near as bad as just connecting the VTX directly to the power distribution board. So this has got a 5-volt out to power the flight controller, and it's also got a 12-volt out to power up the camera and the VTX. So both of the camera and VTX will power off 12 volts. So as I'm using this different power distribution board, I'm going to need some JST cables, so I'm buying these from GearBest here. They're very cheap. For the receiver, I'm going to use the FreeSky X4R SB. You can get this from GearBest, and also the Taranis, which you can also get from GearBest, which I didn't realize. So I like to keep the shop the same as possible when I'm getting these components. And for the FPV video receiver, I'm going to be using my Fat Shark Dominator goggles. Of course, you will need to get a module for that so that it can receive the video. It doesn't come with it. Now, I have bought a load of these. Now, I'm becoming more of a fan of these than an on-screen display. It is a 5-volt buzzer, so I connect a positive and negative wire to this, and then that can connect up to the buzzer solder pad on the flight controller. And then if you plug in the VBAT from the power distribution board to the flight controller, then the buzzer will go off when the voltage gets too low. I'm becoming more of a fan of that than on-screen displays. You don't really need an on-screen display if a buzzer just goes off, unless you're flying long range, which I never do with a micro quad or mini quad. Now, you're not given a battery strap in the kit, which I think is a bit of a shame. Now, I use these really lightweight ones from picnicquads.com. They are really nice for micro quadcopters and quadcopters in general. I mentioned the battery earlier. I'm using this nano-tech battery. It's 850 milliamp 3-cell with a JST connector. Now I'm also, at the end of the video, I'm going to put a 808 number 16 camera on this, and you can get this from Banggood. They are really unrivaled, these cameras. They're tiny, I think they weigh about 18 grams, and they are just perfect for this size of quadcopter. We really need a camera to come in to give us 1080p at this size, which would be quite nice. So of course you're going to need tools for this, such as a soldering iron, cutters, pliers, etc. I'm not going to include the tools in this video. If you want to see a more in-depth video of the tools that you use building these quadcopters, check out my cheap quadcopter build video that I did recently on the channel, and it details all of the equipment that I use. So without further ado, let's get on to the build. So starting off with the power distribution board, I am tinning up the solder pads for the ESCs to connect to. I'll just speed that up so you don't have to watch it in slow motion. Then onto the frame, you're given two different screw sizes with this, so it's quite easy to describe. These are the longer screws, and this is for the nylon standoffs to screw onto. Now these are nylon threads, so I'm just tightening by hand, and then just giving them an extra bit of a turn to make sure that they're not loose, but you don't want to tighten them up with a tool, otherwise the thread will break. And so the PDB is going to sit on the top here. So we're looking at the front of the quad at the top and the back of the quad at the bottom. This is the clockwise motor that's going to go in, and I'm just going to cut these wires short as possible, but just giving enough so that I can strip them and them fit the ESCs. So I'm using a wire stripper here. However, I realized quickly that the cutters are much easier to get into these tiny wires, so I switched to those in a bit. So I'm just lining up the clockwise motor here, and I'm using these screws provided in the motor bag. I'm going to use all four of them using a hex driver to screw these in. Not using thread lock, it's not needed on a quad this small. Just making sure that none of the motor wires are touching each other. I'll tidy that up later. This is the counterclockwise motor. I'm stripping the wire with the cutters this time, and it's a neater job. Again, using a hex driver to screw in the screws, and put them all four in again. Making sure those are nice and tight. And that's the first two motors in. So now I'm taking another clockwise motor and clipping the wires short. And don't clip them too short, otherwise they won't lift up to the ESC. And again, putting all four screws in. The motors fit really nice on this frame. And the last counterclockwise motor, again stripping the wires and screwing them all in with the hex driver. And that's all the motors in. So this is clockwise, counterclockwise, clockwise, counterclockwise. Next, I'm cutting the heat shrink back of the ESC. That's because the ESCs won't fit on the arms if we don't do that. And I'm also going to strip back the pads so that we can solder the motors direct. So making sure that the heat shrink only comes back on the top of the ESC, or the bottom should I say, so that we can access those solder pads, making sure that the ESC isn't touching the bottom of the carbon. Desoldering the ground wire here, so I've cut a little V formation out and unraveling that to just leave the signal wire, because we only need the signal wire for this. Then I'm going to desolder the motor wires. So now if we measure this up, it just about fits, and some of those wires are touching each other, so I have twisted them together and I'm soldering them. Just make sure that nothing is touching. It's quite hard on something this small, but it's a nice neat job if you do it this way. So just tinning those up there, and then these solder really easily to the ESC then. They just directly touch each other. You just hold the ESC in place and then dab the iron on the solder pads, and it's really easy. So now I'm cutting the ESC wires to length. That's the negative and the positive. So these will differ on each motor because they're different lengths. So I'm just tinning those up and using some pliers to put in the ground. It's quite short wire, that one. And then tinning up the positive here and then soldering that in. And then on to the next ESC, again cutting the heat shrink short. Takes a while to do this, but it's worth it. Again, leaving the heat shrink on the back of the ESC so it doesn't touch the carbon. And then on the other side, cutting this short and then cutting in a V formation so that I can remove the ground cable. You don't need the ground to plug into the flight controller on these builds. The ESC is already grounded onto the power distribution board. So this is me cutting the V out so that I can remove the ground. You need to make sure that you don't knock or short these two pads here. So unravel that and clip it off to just leave the signal wire and then remove the motor wires. Tinning up the motor wires now, again ensuring nothing is touching or there's no spikes coming off them, which is quite difficult at this size. It's quite a challenging build, this. It is tiny. Again, just dabbing the iron on the solder pads so the heat shrink is still on the bottom of the ESC, so nothing's touching the carbon. And then this is the last motor wire going in. It's going to be a neat job, this one. So cutting the negative wire to the ESC into the power distribution board, and positive, this time the positive is the shorter wire, and that's because they cross over. But they don't cause too much of a problem. These standoffs are pretty hefty. So dab of the soldering iron for the positive wire and a dab using some pliers for the negative wire. Next ESC again, removing the heat shrink on both sides and cutting a V out on the other side. Desoldering the motor wires. And unsoldering that ground wire and unraveling it and then cutting it off just to reveal the signal wire, and then tinning up these motor wires and then soldering in the ESCs. And again, cutting short the ground wire. I have fed it through underneath the PDB, and I'm just going to tin those up there, both positive and negative. Again, that's crossing over there and using the pliers to put in the negative to feed underneath the power distribution board. Last one, again, cutting back the heat shrink. Takes longer than you're seeing on the camera here. Desoldering the ground and then cutting off the signal wire and desoldering the motor wires. And tinning up the motor wires for the last one, and then soldering it in for a nice, neat job. Again, tinning up the negative of the ESC going into the power distribution board. For some reason, I leave the positive and go straight to the JST connector, so I have cut it to length and I'm tinning up the positive and negative and feeding that through underneath the frame and then out to the sides, and then that's going to solder in the last spot for the power distribution board, and the same with the negative. Then I realized that I missed one of the positive wires out in the ESC, so I'm just soldering that in on the last spot of the positive solder pad. Now I am screwing in the standoffs for the flight controller to sit on. Again, just finger tighten them. And then the flight controller is going to sit on here with the USB port facing the back along with the JST connector. Now I'm soldering up the motor pads or PWM pads, so 1, 2, 3 and 4. And then I'm taking the wire for motor 1 and just feeding it underneath the flight controller so it's a nice neat job, and then cutting that wire short, stripping that wire, and then tinning it up, and that's going to go into motor 1 using the pliers to hold it down. So this is motor 2. I'm raveling it around the front standoff, so this is the front right motor. Cutting this one really short so it's not got far to travel, tinning up the wires, stripping them, and soldering it to motor 2. So this is motor 3. Again, I'm just moving the wire underneath the flight controller, lifting it up and placing it back down, making sure nothing's trapped. No need to cut this one because it's quite short. And then this one is going to get soldered into motor 3. And again, we can cut this one really short because it's at the front, so front left, stripping it and tinning it up. And then that's going to go into motor 4. Next, I'm taking one of the spare PWM wires and using the red and black wire and just cutting it. So this is the wire that is provided in the flight control. We only need one set, so I'm cutting that off, and then I am tinning up the positive of the 5-volt regulator that is on the PDB, and then tinning up this wire here, and that's going to get soldered into the positive there. And now I am tinning up the positive on the flight controller. Sadly, the camera cut off and it missed me soldering in the positive, but you can see it soldered in there. Got a plus and a minus. Now I am staggering the plus and minus, and you'll see that in a bit. Just tinning up the negative wire. Again, it's a spare wire of the PWM harness. And then I'm tinning up the negative on the regulator and then soldering it in. Then you'll see that I'm using a staggered negative pad. You can use any one of these positive and negative pads, just making sure that they don't touch each other, and it works quite nicely. Then I'm just checking out all the wires, see if any of them are going to cause a problem for the flight controller to sit flat, to make sure that none of the wires are going to get trapped, otherwise they could short. Just using a screwdriver to just move them about, make sure they're missing all these JST ports there, and it sits nicely. So now I'm removing the rest of the wires in that PWM harness there, because we only need 3 for S-bus. That's the black, white and the red. So just use a screwdriver to lift up the pins and pull them out. Again, you can use one of these as spare wires for the flight controller's power if you like, but you get 2 sets of these, so I just use the other one. And I actually plug this into the wrong port. It needs to go on the other side for S-bus, but it doesn't matter for just setting up the receiver. I do move it later, so it needs to be on the left-hand port. So now I am depinning and switching over the positive and negative of the wiring harness that comes with the X4R, and that is because I have the EU version of the Taranis, so you don't need to do this if you have the international version. That plugs into the back of the Taranis, and you need to load the EU firmware onto the files inside the Taranis, and that plugs into the S port of the X4R. And I long press the menu button and then page over to where those files are. I put it in firmware, and then we have the EU firmware. You press enter and flash external device, and then press enter, and the lights will start flashing on the X4R, and it will start writing the EU firmware to it. That takes a while to do, so I've skipped it on. Once it has finished, you can turn the Taranis off and then disconnect everything from the receiver and plug the receiver in then. So now I'm putting the aluminium standoffs on top of there to measure everything up. That's all 4 of those. Again, just hand tightened. So next we need to set up a model on the Taranis. So I'm going to press the menu button and go down to a new model. And create new model. I tend to skip the wizard and set it up manually, so you'll press exit there and then page over and then create the model name. So I'm going to call this GB130 because that's the name of the kit. I'll speed that up so you don't have to watch me go through that. Then I'm going to change the model image to TBS Discovery because that's one I know is a quadcopter on the Taranis. Then we need to change the channel range from 1 to 16. I mean, we're not using any more than 8 channels anyway, but it's something I like to do. Make sure you've got all 16 channels available. Why not? And then you need to be in D16 mode as well for that. So I'm also going to set the failsafe to no pulses so that the quadcopter cuts out when it loses signal. Now we need to set up our channels. So it does set up the throttle, aileron, elevator, and rudder, but we need to set up the modes for the different flight modes. So I'm going to change this one to input name mode, and then on the source, I'm going to select one of my 3 position switches. You just need to move it and it automatically selects it. So I'm going to exit out of that and then go over to the mixers, or outputs, should I say, and it automatically selects the output as the source. So I'm just going to change this to M because I don't want to type mode again. I'm just lazy. Then I'm going to page back by long pressing the page button and go back to the inputs and now set up an arming function. I'm going to set this on the only 2 position switch on the Taranis, again selecting it and then pressing exit and then paging over to the outputs and setting that up. And again, it automatically selects the source. I also set up a 3rd for a beeper on another switch. So now I'm going to bind it to the receiver. So I've gone into bind mode, the Taranis will start chirping. You then need to find a way to plug the battery in and hold the failsafe button down at the same time, or the bind button. I just use a screwdriver. Hold it down and then force the battery in. And then that light should flash on the receiver to say that it's got a bind. Then when you let go of that and disconnect the quadcopter, come out the bind mode on the Taranis, plug the battery back in, you should get a solid green light. The next thing we need to do is set the failsafe. So I'm going to make sure that all of my switches are on the off position so that the quad disarms when it failsafes. Then you just take a screwdriver and hold it down for a couple of seconds. And then when you let go, the light should flash and it has recorded the failsafe. So next, I'm taking one of the longer screws that are left. Now, only 2 longer screws are left. And I'm going to take one of the nylon nuts as a spacer so that I can fit my receiver in. And I'm going to do that on the 2 shorter screws as well, but the longer screws are going to have more effect. So I've also installed a buzzer here, but I reroute that, so just ignore that for now. So I'm just measuring this up, putting the receiver in. And I'm going to be building this up, but it's just to measure everything up at the moment for the FPV gear. So I put all 4 of those nylon nuts on, and you can see that it rocks about a bit. It's because 2 of the screws are shorter. So I'm using a hex driver to screw those in. And now I'm screwing the camera temporarily into the camera module. I'm just screwing it one side. Again, this is just a measure up for the FPV gear. That slots over the side of the top plate. It's a really nice design, this is. And this is to measure the length of the wires for the camera. So I know the video wire needs to be short because the VTX is very close to the camera, and this is the positive and negative wire for the power distribution board to go into the 12 volt out. Just measuring that these wires reach. And then the same with the VTX, so I've plugged the VTX cable in, and again measuring the positive and negative wire down to the 12 volt pad. Both of them need to be soldered on. And the VTX is going to sit on the back plate like this with a cable tie around it. And we don't need all of these cables, so I'll be removing some in a bit, but now I'm cutting the video wire on the VTX short. So now I am removing the pins that we don't need. So there's an extra ground cable, which is the black wire, and an extra audio cable, which we won't be using because the camera doesn't have a microphone on it. So removing those 2, and then I'm going to strip those wires with my wire stripper, and then I'm going to tin them up as well. So this is the wire for the camera. Just got 3 cables going into it. I'm tinning that up. And then I'm going to feed that through the top plate so that the wires don't catch any of the propellers, and it's a nice, neat job. So now I am tinning up the positive and negative of the 12 volt out. And then what I'm going to do is solder in the positive and negative of the camera, but I'm going to push the wire through the hole so that it doesn't become desoldered when I come to solder the other wire to it. So both of those push through the hole there, and then I'm tinning up this one. This is for the VTX. Doesn't really matter which order you solder them in because both are going into the same pad. Just make sure the wires are long enough to reach everything. And I'm going to feed that through, just leaving the video wire out. And you can see because those other wires are fed through the holes, they don't become desoldered when I solder up these second wires. So that was the positive, and this is the negative. So I have temporarily put the lid back on, and now I'm sliding some heat shrink along the video wire, and then these two are going to get soldered together. So just dab the iron on that there. And then I'm going to move over the heat shrink and then grab a candle lighter and make sure that is shrunk. So I have added cable ties to the ESCs here as well, but I didn't show that. I'm now feeding through this buzzer here. It just about goes through the top plate as well. It's going to sit nicely behind the camera and the back plate. And then I'm going to solder this directly to the flight controller because the connector that is provided for this is soldered up wrong on the top of the board, and it'll just sound constantly if you use it, so don't bother with that. So that's soldered up there to the buzzer on the flight controller. And then this is for the VBAT. Now this connector does work, so I have cut a length of wire. This wire is provided in the kit. It's a 2-pin JST wire. So that is the positive going into a spare slot on the power distribution board. And this is the negative going in. And we have a mess of wires now that we have to sort out. Again, just make sure nothing is trapped. And then that connector goes into the side here. It's the opposite side to the buzzer. And that will just connect in there, and it'll give the voltage telemetry to the flight controller and therefore your buzzer. And I'm just using my fingers and a screwdriver to poke all the wires in so that they're out of the way. Next, I am fitting the aluminium standoffs on top of the flight controller. And then I'm going to place the receiver with the antennas facing backwards on there. And then I'm going to screw this top plate back in. So I took it apart a couple of times to do that. And then I'm going to plug the camera in, and the wire should just about reach nicely. That fits in there well. Then I'm taking the shorter screws and putting the aluminium standoffs provided in the kit for the camera housing. And there's 3 of those, and that should just fit nicely behind the buzzer, which will sit behind the camera. And then this is the 3rd one going in. And then the other side of the camera plate, and you need to screw in the other side. But first you need to put the back plate and top plate in. Now this is a nice little puzzle here because they keep falling out when you go for put the other one in. So this is the top plate here. You have to play a game of Jenga getting it all together, but it's not too bad. There you go, it just slots in like that. And then you've got the other screws on the other side, the shorter screws. Now, I didn't screw the camera in fully at this point because I wanted to get the angle right, so I usually do that last. So that's 3 screws here going in. A really nice system this is. And then the final screw is going in there. Just tighten everything up. So now I'm plugging in the VTX. It should just about reach if everything has measured out correctly. So I'm then going to put a cable tie through. So I put the back plate in the middle sort of hole so that we can feed a cable tie through the front and back hole to keep the VTX in place. And in a crash, this cable tie should snap and shouldn't damage the VTX. Of course, we need to put the antenna on before we boot anything up. and the antenna will bend upwards quite nicely. So that cable tie goes in nice and tight. I'm going to clip those short. Then I'm going to use 2 smaller cable ties and feed the antennas upwards, and they should be short enough not to touch the props in a crash because I fed them backwards over the receiver. So I'm just tightening that up and cutting it short, and the same with the other side, and all of the wire should be nice and neat. It's a really nice, neat build this. So I'm screwing in the antenna now, and that will bend upwards. I really like this build. Lastly, I'm putting the battery strap in. You're not given a battery strap in this, so I'm using one from Picnic Quads. Really like their battery straps. That just tucks in underneath there. Really nice and neat and lightweight. So here we are in Betaflight. Now I have already set everything up on the flight controller, and I'm just going to show you the settings that I changed. If you are interested in seeing a full Betaflight install, then check out my cheap quadcopter build that I did on the channel a couple of videos back. So to flash the firmware, you need to go into the firmware flasher, select SP Racing F3, and then the latest version of Betaflight here is 3.01. You need to check the manual baud rate at 256000 and then load the firmware online. And then once that's done, select the correct COM port at the top and then flash firmware. But of course I have already done that, so I'm going to connect to it. So you're going to want to calibrate your accelerometer here. Under ports for this particular board, you need to check serial RX for the UART3. Under configuration, we've got quad X selected here, and one shot 125. I've got disarm the motors regardless of the throttle value enabled, but motor stop is turned off. I have got the center PWM throttle value at 1500, the minimum throttle at 1040, and the maximum throttle at 2000 with the minimum command at 1000. So I've got the VBAT enabled for the buzzer. I have got serial RX enabled for S-Bus, and then S-Bus selected down here. So these are the stock values for PID loop frequency and gyro update frequency. I will not be changing those. I've also got telemetry enabled here as well. So I've got expert mode turned on. If we're going to failsafe, I have set it to stage 2 and set it to drop. Under PID tuning, you can use my PIDs here. I have set the roll and pitch to 60 on the P and the yaw to 70, integral 4.5 and derivative 60. RC rate at 1 and the super rate at 0.80 and RC expo at 0. I have my angle and horizon strength at 50. Now for the receiver, I'm going to need to plug in the quadcopter because the receiver doesn't boot up unless the battery is plugged in, so I'm going to do that. And then you'll see all the values here. And the channel map with the Taranis is TAER1234. If we go into the modes, I've got my arm on a 2-position switch. I've got angle mode on a 3-position switch along with horizon and acro, and I have set up an auxiliary 3, which I didn't show earlier, but it's just an extra auxiliary channel to have a beeper go off if the model gets lost in long grass. You can flip a switch and the beeper will go off. In fact, I should be able to show you that. Like so. So of course you're going to need to calibrate the ESCs, and the way that you do that is make sure you've got all of the props off. You tick this button here and put the master to full and then plug your battery in and you'll get the magic tones, and then you drop the throttle until the ESCs have finished calibrating and they will reset and they are calibrated there. So that is all the settings in Betaflight. Next I'm going to show you how to change the motor direction in Blhelisuite. So you have to make sure that you have disconnected from Betaflight, and then select the COM port here. Under the pass-through, we want clean flight selected there, and I'm going to press connect. And what you need to do then is press check. And you can see here that I have got motors 2 and 3 reversed. So when the motors are soldered directly to the ESCs, they all spin clockwise. So motors 2 and 3 needs to be anti-clockwise or counterclockwise. So I have gone and done that. And the way that you do that is you have to individually select the ESC. So ESC2, and you can see that motor direction reversed, and then you press right setup and uncheck that one and check that one, and again change it to reversed and then right setup. You can see that motors 4, the rotation is normal, and the same for 1. So when you're happy with that, you can do right setup, and then all of your motors will spin in the right direction. The next thing to do is put the propellers on and go and fly it. Now the nuts are directional, so the black ones are for the clockwise motors and the silver ones for the counterclockwise motors. I'm just hand tightening them for now. Now you do need to tighten these up really tight because there's a bit of a design flaw with these nuts in that the locking part of the nut does not reach the thread of the motor. But that's not really a problem because they are directional. And if you tighten them up really tight, they're not going to come off. But yeah, a bit of a shame that. So just tightening them up with a wrench. And lastly, I'm screwing my camera in, so there's 2 screws there, and we are ready to fly. Okay, let's get a Maiden this thing. I'm going to keep it in angle mode. I'm going to stay a fair distance away from it just to arm it. This is my arming switch, so let's see if it works. Everything looks good so far. And there we go. Pretty uneventful. Wow, this feels nice. Do a punch out test. Wow. I did not expect that after flying that P130. The P130 has the wrong motors. Look at that. Hey, the tune feels pretty good. Okay, let's try some flips with it. Ooh, snappy. That tune feels really nice. The thing is so small, I'm struggling with my orientation with it a little bit. Not too bad though, I have to say. I think this thing's going to be fun. It's so fast. Okay, let's bring it in for a landing and do some FPV. But so far, pretty impressed with that. So I've got my 808 camera strapped to the front of this, and you're about to see why I did not build this with a 4S, and it really doesn't need it. The thing is absolutely ballistic with 3S. And this is the FPV feed that you can see here. There's a little bit of interference from that regulator, but it's not too bad at all. I guess a better PDB would get rid of that. So the tune with this thing is absolutely fantastic. I'm really pleased with how it flies. And just look at how much punch there is with this thing. You definitely could confuse this with being a 4S model. It certainly feels like one. I guess the thing is just so lightweight with such a huge power to weight ratio. I imagine a 4S 130 built like this would be absolutely crazy to fly. But this one is just manageable, and I really like how it flies. I am going for one of my Cubinates that I like to do, and it's flying really nice. Now, unfortunately, it was a very dull day, and it was spitting of rain. It's really hard to avoid rain this time of year. It was pretty calm though, but there's no problems flying this in the wind at all. I really like that FPV camera at the front. I've got it angled at about just 10 degrees for doing some freestyle. Now you might notice that the video is pretty smooth. I have converted both the FPV feed and the 808 feed to 60 frames per second. If anyone's interested in how to do that, I will show you. And what I love about this 808 camera is it's been out for a couple of years now, and it is still relevant in the hobby. And I think it's going to be even more popular because these race quadcopters are just getting smaller and smaller, perhaps due to restrictions and regulations, and we're going to need smaller cameras. Now I think a Session 5 would probably sit on the top of this quite nicely, but the 808-16 is just perfect for me. It doesn't give you that 1080p quality, but 720p, it's a very good 720p compared to the other offerings out there. Nothing has come along and beat it in my opinion. I think it weighs about 18 grams, which is nothing. And the quality is just superb, especially for this small flying quadcopter, which you want to keep as lightweight as possible. And the flight time was pretty impressive with this 850 milliamp battery. I was getting 5-minute flight time, which is a little bit more than I get from my 4S 230 quad that I built on the channel, so I'm having a lot of fun with this one. This is why I spent the time showing how to build it, because it's a really nice setup. I love doing this flying above the trees, and there's just so much power to punch out of the bottom. You don't need to worry about it hitting the ground. And the tune's really nice, no wobbles at all on the rolls and the flips. I'm really pleased with that. Hardly any vibrations on the camera. And these cameras are susceptible to vibration, so that just shows you how good these motors are. And that is the thing I'm most impressed about with this build, is those Emax motors. I flew the P130 not so long ago, and it didn't perform like this at all. They should have teamed up with Emax like they did the P200 and put these motors on it, and I'm definitely going to be doing that. I will put links in the description of all of the components that I used in this build if you wish to buy them and follow along, or if you want to buy different components, then the method will still be the same. So there you go, that is my video on how to build a brushless 130 model. As always, thanks so much for watching. Please continue to subscribe. Cheers.